didn't really get a chance to see what I have put in the WhatsApp saying what we are going to learn today. So primarily we'll focus on two last topics for this unit. One is polynomial equations and graph, and then second is rational equations. Okay, and that should complete this unit for us, and then we will try going to the questions that Isha had sent. 6 questions, out of which 2 we had solved. Hey Ritvik. And Loder. So one last request, okay? Ask you all to be on video. Again, that's very much needed so that we can make eye contact and I can get a sense of how much I'm able to explain you guys. Okay? I know it's not mandatory, but prescribed. All right. So yeah. Just to begin, there are 2 things that we're going to do today. That's for Unit 12 of the Italicity Prep, and the other 2 last topics. One is polynomial graphs and rational equations and graphs, and some of the behavior and properties that we'll see. And then we'll start solving those remaining 4 problems that Isha had given us, given me rather, which were not solved yet. And we'll see with whatever we have learned, how many of them we are able to solve, and if there is something that is missing, apart from what we have covered, I will solve it offline and send it to you guys with respect to how this should be done. Is that okay? Everybody with me? Everybody can hear me fine?
Yes, sir.
Okay.
Yes.
Alright, so first, starting with polynomial equations and graph. Now, when you say polynomial, what do you mean?
Sir,
Yep.
sir, polynomial is an expression that has more than 2 algebraic terms.
2 or more terms, yeah. Poly stands for many, and it always relates, polynomial here in algebra, it relates to the number of terms that you have in an equation or expression. Okay, so when you say polynomial equation or expression, you're talking about an equation or expression which has multiple terms. Now there are multiple things that we have done with the polynomial equations or expressions. So what is new that we are going to do, right? So we have looked at y equals ax square plus bx plus c. Or even if I don't write this as an equation, if I say this as an expression, then also I'm talking about 3 terms, right? And this is predominantly a quadratic expression, or if I put a 0 here or put a y here, it becomes a quadratic equation then. So it is still a polynomial. So what extra we are going to do? We are going to look beyond the exponent too. Basically, so far we have seen 2 types of equations. One is linear equation, which has exponent, maximum power of the exponent is 1, and that helps us draw a straight line. Then we looked at quadratic equations or expressions where the power of the exponent, maximum power of the exponent was 2. So here the power of the exponent or the variable is 1, here the power was 2. So this was the quadratic equation, even if it has multiple terms. And then we looked at exponential equations also, or we plotted graphs where my second variable was nothing but in the form of the exponent. Yeah. Now we are talking about polynomial equation again, or polynomial graphs. What we are essentially going to do is, we are going to do something beyond what we have done so far. Meaning, we are going to go beyond power of 2. Okay. So, look at this equation now. X cube plus 6x squared plus 5x plus 7. what is the maximum power of the variable? Is 3. So, and how many terms we have? Multiple terms. It's a polynomial equation for sure. But then we are talking about the maximum power of the variable as 3, or the exponent as 3. So it is going beyond quadratic equation. Again, with quadratic equation, there is such a generic thing in nature. There are a lot of things that we talked about. We learned about factorization, how to solve the equation with factorization by applying the generic rule that we have for a plus b whole square, a minus b whole square. Or then we learned the way to find out the solution for a quadratic equation by use of discriminant, right? A racist thing that we talked about, yeah. So again, that is what. See, if I say something which is unofficially or officially incorrect, there is no intent. Okay, it's only to make you guys remember things. Okay, there is nothing else. I was teaching kids how to convert a fraction to a decimal, and I explained them it is more like a chicken and egg. A decimal is like a chicken which lays one egg at a time. And that's how I explain that. It has no bearing with how math is to be understood. I just add some element to make it a little more interesting for you guys. Okay, so if I say something which is not right, just keep the intent in mind. It is only to make you realize or understand or remember things in a better way. That's all. Okay, coming back to this one. So where were we? I was talking about an equation with power more than 2 for the variable, and this is the equation with, it's again a polynomial because it has multiple terms, and then maximum power is 3. So even if I have equation like this, it is still a polynomial because it has 2 terms, yeah, and the power is more than 2. There could be a situation where you might say, okay, y is a function of x, and it is like, okay, 5x to the power 6 plus 6x4 minus 27. Same thing. It is more than a quadratic equation, power is more than 2, and it is a polynomial. So we are going to look at what happens to the different types of graphs. Like what I was saying, you have different options. Yeah, now I remember where did we take the diversion, right? I was talking about the quadratic equation, then I was talking about the discriminant, and I went in a different direction. Okay, so coming back to this, these equations, you will not have any standard approach for solving them like quadratic equation. Only option we have is break it down into smaller pieces, still try factorizing them. It will not be as easy as it is with quadratic equation, it will be more complicated, and you will not get a lot of questions around these ones, but it's okay to understand conceptually what it means. So now, before I keep blabbering, anything that I have made confusing for you guys so far, just let me know. And it's okay. I mean, you guys are grown up, okay? You can certainly share some feedback. Let's say if I'm going in the wrong direction, not making you guys understand something or appreciate something, stop me saying, sir, probably this part I did not understand. That's okay. That's fine. Yeah. So far, everybody is with me. Nothing difficult to follow. Okay. Now look at this equation. Okay. Here, what you will see is, okay, one simple question to you guys. If I had an equation like how many possible solutions we get here for x or y? We get many, but let's say I'm saying, if I try solving this for x, meaning if I say one value of x, yeah, I mean you're right, but let's look at this. This is a linear equation for sure. Let's say there's another linear equation. Why do we get 4x always? When you try solving this, you have two equations and two variables, right? We can solve this and we will get corresponding value for x and y. It helps us solve for one value of x. It gives us only one value of x here and one value of y. If you look at a quadratic equation, something like 4x squared plus 6x plus 9 equals 0. Or let me give a different equation. So this is one equation. This is another equation, let's say 5x plus 9 equal to 7. This is a linear equation. This is a quadratic equation. If I say 5x cubed plus 7x squared plus 9 equals 0. This is an equation, it's a polynomial with maximum power as 3, and I can simply go on. Now if you look at this equation and this equation, this equation. If I solve this one, how many value of x I will get? Only 1. If I solve this one, how many value of x I will get? 2. Yeah? If I solve this one, how many value of x I can possibly get? 3. Yeah? We'll get 3. So the reason being, the number of power of x determines how many possible solutions you can get. Now, look at it a little differently. When I have an equation like this, I can solve and get 3 values of x or 2 values of x depending on the power here. Imagine if this was written like a graph, a function like this, where y is a function of x and y equals to 4x squared plus 6x plus 9. Meaning, if this helps me get 2 values of x, right, without y, that means for every possible value of x, I can get that many values of y also. Yeah? Here, or look at it this way. When I am trying to solve this equation, what do? I say, okay, fine. When y equals to 0, then let's solve it for x. And when you solve this one, this gives you 2 values of x. Let's say x, one value is, let's say 5, another value is 7. What this means is, when y is 0, these are the values of x. What it means is, these are the places where y is 0, meaning this graph is touching the x-axis. When will y be 0? There is only one place in the world where value of y coordinate will be 0, that is x-axis. Any point on the x-axis that you pick up, the y value will be 0. Yeah? Everybody with me?
Yes, sir.
Yes, sir.
So, now you try relating it with this one. When it's a linear equation, when y is 0, for that, if you, let's say if this was the equation, this is a linear equation, it plots a line. When I put a y as 0, that gives me a value where this line touches the x-axis. It gives you the value of x as something. Let's say here if I give y as 0, so x comes as minus 9 by 5. So this is where y is 0. So this becomes my coordinate. If I am looking at my graph, x is minus 9 by 5. So it's little less than 2, minus 2. It is minus 2 here, so maybe this is the point here. This is where this line will cross x-axis. Maybe this side, maybe this way, we'll figure it out. Yeah? Now, when I'm looking at this equation, quadratic equation, y equals to 4x squared plus 6x plus 9. And I say when y is 0, then I solve it for x. I get 2 values for x. So it gives me y equals to 0 and there are 2 values of x possibly. Okay, I've not solved it, I'm just guessing it right now. So these values that I get, what this tells me, that these are the points on the x-axis. When x is 5 and x is 7, this is where this graph is going through or crossing the x-axis. or these are two places where it cuts the x-axis. If I'm talking about this is my, let's say this is my polynomial equation. Here I can solve it for 3 values of x, meaning when I say y is 0, when y is 0, that means this is equals to 0. When I solve it for x, it gives me 3 possible values of x. Those are the points or the coordinates where this graph will cross the x-axis.
Sir?
Yeah? So, yeah, Babu, go ahead.
I have it all.
No, I did not hear that. Say that again.
I have it all.
You have it all?
Yeah, doubt.
You have a doubt. Okay. Yeah, go ahead.
So like, if the exponent, like the degree is more than 2, so it's not a quadratic equation?
No.
Oh, okay.
So basically, that's why it is given a generic term saying polynomial. Meaning where you have multiple terms and the power of x could be anything different from 2 or more than 2 basically, because when the power of x is 1, it's a linear equation. There is no doubt about it. Why would you, even if it has multiple terms, why would you unnecessarily complicate it by calling it a polynomial? Because that's a linear equation for me. That plots a straight line for me. Now, when I have power of 2, it draws a parabola. Be it this way or be it this way. It's a parabola. It has power of 2. That is all written in stone. Nobody is bothering to touch that or redefine that. So that's why this polynomial term or polynomial graph is used for everything else that is not covered. Meaning power 3 more or 4, 5, 6, you can go on as far as you want to. Okay? So that is what we are trying to look at now here. So we are just trying to relate. Now we saw that if it's a linear equation and if I give the value of y as 0, meaning that tells me if y is 0 in this linear equation, meaning that gives me the value of x, and that will be the point where this line will cut the x-axis. Because y value being 0, there is only one possibility. This is where it is cutting the x-axis. Okay. Likewise, in the case of a quadratic equation, when y is 0, meaning I am saying yeah.
So how much inner vertex is with this equation?
I will come to that. So that's why I'm just trying to inject this concept first. I'll come to that. Okay. So now, when I have a quadratic equation, it draws a parabola. When I'm saying y equals to 0 in the in equation, that means it tells me these are the points where the parabola touches or crosses the x-axis. Okay. And again, it's a parabola. This solves or gives me 2 possible values of x. So maximum 2 points could be there where it will touch the parabola or touch the x-axis. Now I'm trying to relate. So hear me out carefully. Okay. When I had a linear equation, it was cutting the x-axis in one place. When I had a quadratic equation, there was a possibility of it cutting the x-axis in 2 places maximum, up to 2 places. Yeah. When the discriminant is 0, there will be only 1 point, right? It will cut only at one place. Now, when I'm looking at an equation with power of 3, when I'm solving this for y equals to 0, it gives me 3 possible values of x. That means this can cut the x-axis at 3 possible places. If I have an equation with power of 4, you can simply extrapolate whatever we have learned. If it has a power of 4, if you solve it for y equals to 0, you will possibly get 4 values of x. That means it can cut at 4 different places. It can cut the x-axis at 4 different places. And we can simply go on. Up to this much, any doubt, any confusion?
No, sir.
No? Isha, Atharv, Sivatsav, Rutvik?
No, sir.
Everybody is okay? Okay. So, now let's relate this. So whatever I said, look at this. This is my linear equation, y equals to 5x plus 7. I'm just making it up, okay? This is a linear equation. When y equals to 0, what is the value of x? Minus 7 by 5. Whatever it comes, you get one value of x. And whatever value you get, that's what tells you that, okay, this is the point where it will cut the x-axis. It can cut x-axis or y-axis at only one place, no matter how intelligent we become. A linear equation will cut only one place. Very simple. Now, let's look at the second scenario. We are talking about a quadratic equation. Y equals to 36x squared plus 25x minus 7. Now when we solve it for y equals to 0, it gives me two possible values of x. What that means, this is a parabola. Whatever is my solution for x, those are the places where it is cutting the x-axis. And now look at this. When you were looking at straight line, you had only one direction, one point, one way to move. When you're looking at a quadratic equation, power of 2 endpoints. I mean, this also had two endpoints, but it was giving only one direction. Here, one is going in this direction, one is going in this direction. Yeah. Now you are two endpoints giving two different directions to this. Now look at third scenario. Let's say I have power of 3. That means it will solve for three possible values of x for y equals to 0. That means this is how it will be. Here also you have two endpoints for sure. But then here also you have two endpoints. Here also you have two endpoints. But look at the shape of the graph. More the power, more the curve. See, when you had power of 1, no curve. You have power of 2, 1 curve. When you have power of 3, 2 curves. This is why it's touching it at 3 places, depending on how you solve it. I mean, once you solve this for this one. Okay? If I have something called if in the exam you get that, okay, this equation, this polynomial will be plotting a graph, and if it stops here, you see that there is a power of 4, this is not possible. And if you have an option which says, then you know that this could be the right answer. If you have to choose between this one and this one, this could be the right answer. Now, there is one more thing that we have to notice. See here, this topic that we are learning is more about the inferences that we are drawing based on what we have learned so far. Now look at this here. I said, if I have power of 1, no curve, 0 curve. If I have power of 2, this draws a parabola, 1 curve. If I have power of 3, it draws 2 curves. If I have power of 4, it's drawing 1, 2, 3 curves. Now look at another thing. If you're looking at parabola, power of 2, all pointing in one direction, both pointing in one direction, upward. Power of 3, pointing in two different directions. Power of 4, pointing in the same direction. Another interpretation here, if the power is odd, that the two endpoints will point in opposite direction. If the power is even, it will point in same direction, the two endpoints. So see, here the power is odd, pointing to opposite directions. Power is even, square, power is even, pointing in the same direction. Again, power is odd, opposite direction. So whenever it's odd, not symmetric. Whenever it is even, this comes together. Any questions?
No, sir.
No. Okay. And these are the what you call. See, I would not remember this, or I would have not remembered this after this long, right? After having grown this many gray hairs, I would have certainly forgotten. But since I was reading for teaching you guys, so I could relate. I could refresh my memory, right? Same thing for you guys also. Even if whatever we do in the class, I can tell you that even if I would not brag about it, I would not say that I'm the best teacher, but regardless of how good the teacher is, whatever we learn in the class, there's a high possibility of we forgetting things also. So, and that's the reason why whatever we do, we record it and put it on for your reference. I would suggest you guys to just spend 5, 10, 15, 20 minutes just to skim through. Now, wherever I'm blabbering, giving you unnecessary theory, skip that part. At least the things which is important for you guys, just revise it, take a note of it, so that it turns out to be handy. See, I'm not a YouTuber. I'm not uploading video on YouTube just to create subscription or to get views, right? It is only for my students, all my kids, so that whatever we learn, we have a repository to lean on if we keep forgetting. And we trust me, as a human being, we keep forgetting. Okay? So make use of these videos for your benefit. I'm pretty sure this would at least help you recall things. Okay, so whatever we have done here, these are all interpretations. Now, let's look at some more things. So when we talk about polynomial graphs, essentially we are talking about equations which are plotting graphs with multiple terms, and specifically here we are talking about equations with power more than 2. Okay. Now, so let's look at scenario like this. And you would see that I'm not solving these equations, because if I try solving it, it is possible to solve, but the only thing is this will be beyond the need for you guys from SAT point of view. Okay, there's another thing that you will end up solving when you go for becoming a true mathematician in the college or beyond. Okay, so that's why I'm not trying to solve it, but at least trying to give you guys the concept. Now here, the same equation can be written as x minus a into x minus b into x minus c. And a, b, c are unknowns. We have not solved it. This is called the x-intercept form. This polynomial, right? When we are talking about an equation which is having power 3, this can solve it for 3 values of x, and these are the possible values of x. You can look at, see, you will get questions saying, okay, I have an equation in the form of this, so find out what is the what are the points where it is cutting the x-axis. Or it might say, okay, my graph which touches the x-axis at 3, 2 and minus 1. Find out the equation for this one. So then what you will do is, you will put the A, B and C in this equation, multiply it and find out the equation for that. That's it. So, okay, so let's not go to the problem first. Let's try understanding this one. So this is called the x-intercept form, where A, B and C are the points where the graph is touching the x-axis. So that is why it is called x-intercept form. So let's say, coming back to the question that I was saying, that if you get a question saying that my graph is touching x-axis at minus 2, minus 1 and 3, find out the equation. Since you have 3 solutions, 3 values for x, where it is that are 3 places where it's touching the x-axis, that means it's an equation with power 3, and this can be represented in this form. So you will just put x minus a. Here it's minus 2. So x minus 2. This is first one. Second one is x minus b. So x minus 1. And then x minus c. X minus, here it is 3, so it is like this. So it becomes x minus into minus plus, so x plus 2 multiplied by x plus 1 multiplied by x minus 3. So this becomes your equation. You can break it down. So x plus 2 into x plus 1, then you multiply, it becomes x squared plus 2x plus x plus 2. So it becomes x squared plus 3x plus 2. When you multiply these two, now you have to multiply this with x minus 3 also. So you first multiply everything with x and you multiply everything with 3. So it becomes x cubed plus 3x squared plus 2x and then minus 3 into x squared, so minus 3x squared. Minus 3 into plus 3x, so minus 9x. Minus 3 into plus 2, minus 6. Now you will say, okay, minus 3x squared plus and 3x squared minus. These two gets knocked off. Now it becomes x cubed plus 2x minus 9x. So this becomes minus 7x. And then, then minus 6. Yeah. So this is what becomes my equation. Okay. So basically what I'm saying is this is the x-intercept form. It says that if I have an equation with power 3, meaning it's a graph that is cutting the x-axis at 3 places. This is one simple way to represent this one. Okay. Similarly, if the graph is cutting at 4 points, then you can simply extrapolate that x minus a into x minus b into x minus c into x minus d. Y equals to this. This will be your equation. Now, since you know the 4 points, you will put the value and you can play with it. Okay. You will not have any complex calculation like what we have with quadratic equation. This is more about extending that information to use something more generic in nature. Any questions so far?
No, sir.
No?
No, sir.
Okay. Isha, are you with me so far? Yeah?
Yes, sir.
Okay. How about you, Ritvik?
Yes, sir.
Okay. And guys, don't have to be shy, okay? If I'm not teaching you well, just say that loud and clear, that's fine. Say that, sir, this one is not understandable. And I have to repeat, right? So my request to you guys would be, you guys are grown up, intelligent, sensible, and respectful also, right? So don't have to be shy. It's okay. I mean, you are here in the class, spending 1 hour with me to learn something. If you're not learning, stop me. Okay? Alright. So this is the polynomial equation, the polynomial graph, and we use this for plotting it. Now, there's one more thing that I had mentioned about the polynomial graph. What was that? Do you guys remember? Polynomial remainder theorem. Okay. So let's say if I have a polynomial equation, I will write this as px. Okay. Polynomial function. Okay, which is plotting a graph for me. As, let's say something like this. Let's say 5x cubed minus 7x squared plus 20x minus 22, let's say. Okay. It again gives another theory. It's a theorem, it gives a theory. Saying that if polynomial, this is my polynomial function, okay, or equation or expression, whatever it is. And then p polynomial of x minus a it says for a polynomial function or expression, if x minus a is a factor, if x minus a is a factor of this, oh, who joined? I see. Okay, I thought I joined from two places. Okay. So, if I have a polynomial function like this, and x minus a is a function, is a factor of this expression. See, I can say this equals x minus 4 multiplied by something like x squared plus 5x squared plus maybe 3x minus 7. That's it. I said this expression can be broken into two factors. Okay. So this one says, if for a polynomial function, if this is a fraction, x minus a is a fraction, then p of a, this a, will be the remainder of. Now when you divide this by x minus a, this will be your remainder actually. So imagine, let's say for whatever value, let's say for this x minus a means what? This is a place where this is one value of, so basically we have just factorized this and this is one factor. Okay. So if this is a factor, let's say if you're talking about x squared plus 7x plus 12. So when I factorize this, it becomes x plus 4 into x plus 3. This is one factor, this is one factor. We factorize this expression. Same way it says, in a polynomial, if this is one of the factors, okay, meaning if you use this as a factor, then this will be a remainder. Meaning, if you divide this thing by this, then this is what will be a remainder. Statue. Everybody is frozen. Okay. Let's look at it in a very simple way. You have a polynomial expression, and first thing we said that, okay, if I have a polynomial expression which with power 3, this is x-intercept form will be like this. I can repaint this in the x-intercept form like this. This is what we talked about, right? Now this gives you one more theorem, because we are not trying to solve this. This says, it's called polynomial remainder theorem, meaning if you have a polynomial expression like this, and you have, this has one of the factors, then meaning if you divide the polynomial with x minus a, then the polynomial for that value, meaning when you replace x with a, whatever value you get, that will be a remainder. Or let's look at situation like this. If you try relating that as a solution, what will happen is, let's say my expression is this. What we are saying is x minus a. So here I am saying a equals to 2. Okay. So x minus a, x minus 2. So this is my expression, and this is my x minus a. This is one of the factors, meaning I am splitting this into a into b form. If this is my factor, then p of 2, meaning I put 2 in place of x, so it becomes 5 into x cube, so 2 cube, minus 7 into x squared, meaning 2 squared, plus 20 into x, that is 2, minus 22. So this gives me 5 into 2 cube, that is 8, 5 into 8 is 40, minus 7 to 2 squared, 4, 28, plus 20 into 2 is 40, minus 22. This gives me 80 minus 50, so this is 30. So this will be the remainder, meaning if I try dividing this with my x minus 2, this will be my remainder. This is just a theorem, okay? This was given by some Greek mathematician as a remainder theorem. I tried finding out how it is solved, how it is proved. I could not find any evidence of that one. Okay, I'll keep looking for it, but this is just that's just called a polynomial remainder theorem. Even if you don't remember this doesn't do any harm, because you know the things like the when depending on the power of the exponent of x, right, that many curves it will have, right. Then we talk about how many endpoints it will have. Sorry, it will always have two endpoints, but whether it will be the same direction or opposite direction depends on whether it's the power is odd or even. And then we learn about the x-intercept form, which tells me how I can break this into x minus a into x minus b into x minus c, depending on what is the power. So if I have two power, let's say if I have x 5x square plus 2x plus 7, this is a power 2. So I can break this into x-intercept form as x minus a into x minus b. If I have power 3, it becomes x minus a into x minus b into x minus c, where a and b and c are intercepts, meaning this is where it touches the x-axis. Okay. So polynomial remainder theorem, even if you guys don't remember, that doesn't do any harm. But if you remember, if you just while reading, if you just go through it once, and if you come across any problem with that, it is like a 2-minute thing that you have to remember. I mean, I could not find a way to prove it, so that's why I'm just giving you guys another theorem. Okay, for now. If I find something in between, I will tell you guys now. Are we good with whatever we have learned so far? Okay.
Yes, sir.
Okay. Okay. All right. So now let's look at one more type of equation or a graph that is called rational graph or graph with rational functions. What is a rational? Whenever it's in the form of a fraction. If I say y equals to function of x, which is equal to 1 by x minus 3. This is a rational function. Okay? Where one of my variable is in the form of a rational number. I mean, everything in the world is rational number, but I'm saying which is in this form, meaning where one of the variable is in the form of a denominator. Now, when I say this, what happens? Now let's look at this. Let's try plotting this. So y is 1 by x minus 3. Okay. When x is 1, let's say when x equals to 0, what is the value of y? It will be 1 by minus 1 by 3. So when x is 0, y is minus 1 by 3. Okay. It's probably somewhere here. Okay. Now, when x is 1, it becomes 1. So it becomes 1 minus 3. So again, minus 1 by 2. Okay. When x becomes 2, it becomes minus 1. So when, oops, what did I do? I just started thinking why it is not looking like a graph so far. So when x is 0, y is minus 1 by 3. So when x is 0, y is 1 by 3. Here, somewhere here. I'm saying this is 1. Okay. Now, when x equals to 1, what is the value of y? Minus 1 by 2. So when x is 1, 1 by 2. Here it is 1, 2, 3, 4, 5. When x is 1, y is minus 1 by 2. So it's somewhere here. Okay. Yeah. Now when x becomes 2, y becomes minus 1. So what am I doing? This 1 by 2 will be here, somewhere here. That's why I was wondering where my graph is going. Now when x becomes 2, y becomes minus 1. So this is my second point. This is my third point. So this is how the graph has been going so far. when I give x equals to 3, this is when the fun begins. When I give x equals to 3 here in this function, it becomes 1 by 3 minus 3, 0, undefined. So this state of undefined, a function, a rational function gets into undefined state for certain value of thing. Okay, and so you will see that till it is less than 3, x is less than 3, it is still fine. As soon as it becomes 3, it becomes undefined. So here no. So till this is x equals to 1, this is x equals to this was x equals to 1, this was 2, and this is 3. So my graph will be something like this. It will not go beyond 3. So let me plot it little clean so that it becomes easy. Let's say this is what x 1, 2, 3, 4. Okay, minus 1, minus 2, minus 3, minus 4. So we'll spend a little bit of time on this one, okay? Just maybe 10-15 minutes, just to understand this one conceptually. Again, here also there's nothing complicated. It's again about solving the, looking at the function, seeing what the behavior is, and then relating to that. There's no formula, nothing to memorize, but again, it's very important for us to visualize this so that we don't go wrong. Let's say this is my function, okay? So let's say I'm saying this is minus 1 by 3, minus 2 by 3, or let it be, and this is by 1, minus 1. This is plus 1 by 3, and this is 1. So this is 2, 3. Now when I say x equals to 0, what was the value? Minus 1 by 3. So x equals to 0, this was my first point. Now when x became 1, what was my value of y here in this function? When x became 1, it became 1 by 1 minus 3. So 1 by minus 2. So minus 1 by 2. So when x was 1, it was minus 2 here. Okay. When x became, not here, maybe here. When x became 2, it became minus 1. So it is minus 1 here. So let's look at this. So here, when x became 2, it became 1 by minus 1. So minus 1. So this was my second point. Now look at this situation when x becomes 3. Okay, I will not say 3. Let's say 1 by, this becomes 2.5, because I know when it becomes 3, it becomes undefined. 1 by 0 is undefined, right? Infinity. So I will say x equals to 2.5. Let's see what happens. If I say 2.5, it is 1 by 2.5 minus 3. So 2.5 minus 3 is how much? Minus 0.5. Minus 0.5 gives me a 2. So you will see that, let's say this is minus 1, okay? So that way it is, I have an option to play with this. So when I had 1, it was minus 1.2. When I had 2, it became minus 1 here. And when I gave it minus 2.5, so I gave x as minus 2.5, minus 2.5 made it 2, so it came here. So you will see that this graph will start going like this, will go downward, 2.5, 2.6. See, so far it was going horizontal and all of a sudden it starts going steep. So you will see that when it is approaching 3, it starts getting steep. So this is called the x asymptote. Meaning, this graph will never touch this line, but if it touches this line, that is when it becomes undefined. Likewise, if you're looking at this rational function, here also there will be a situation like this. Okay? There will be certain value of x or certain value of y for which it will become horizontal. Okay? So that makes it the y asymptote. So basically, if you look at any rational function, it plots like this. If you look at any rational function, it plots like this. Okay? So you will have one asymptote in this direction, which will make it undefined, right? Let's say here we are talking about x equals to 3. X equals to 3 makes it undefined, almost go vertical. Imagine if x becomes so big, maybe infinity, okay? Then y becomes almost 0. If x becomes infinity, too big a number, maybe 10 trillions, what is the value of y? Point something here, right? Point some after 10-15 decimal points, some number. So when x becomes very big, so there are two directions actually. When x becomes very big, very big, you will see that. So this graph plots in two directions actually. So whenever you see a rational function, you will see that there is a graph plotted in two directions. One is when this value makes it undefined in one direction, and one scenario when it changes in the other direction. So that is how you will see the rational functions will plot a graph which is not one way, because it becomes undefined in two directions. Okay? There will be two scenarios which will make it undefined, and it will plot it like this. Okay? Because when you go in one direction with all positives, it will plot something. When you go negative, it will plot something else. And that is how you will see two scenarios when it cuts across a borderline case where it becomes undefined. Because you have a numerator and denominator. If the denominator gives a value, if you try dividing something by 0 or infinity, those are scenarios when it will become undefined, and that is why you will end up seeing these dotted lines in your graph, which is called asymptote. So asymptotes are nothing but a borderline scenario for two possible values in a rational function where it tends to go to undefined state. So here in this case, x equals to 3 gives you this situation. Okay? And then when you say y equals to 0, y equals to 0, so this is where y is 0, right? Along this line you will see that when y is 0, that means this is when x is way too big. When will y become 0? When the denominator is almost infinity. You divide some number by infinity, that is when you get a 0. So when you are along this line, you will see that when exactly cuts the x-axis, this is where this is becoming undefined. So you don't have to memorize this as in this form. You have to only look at asymptotes in a rational function or the two borderline scenarios or the two axes along which the value of the function becomes undefined. Okay? So let's do a recap of what we have learned so far. So we looked at polynomial functions, and polynomial functions or the graphs are nothing but an extension of what we have learned so far with linear equation and quadratic equation. This is just power more than 2 is what we were talking about. And we looked at different possible graphs, what is the possible value of x for a given value of 0 as for y, and when we solve for that, it gives us how many times it is going to cut the x-axis. Then we looked at certain behaviors when say, okay fine, if it's odd what happens, if it's even what happens, right? that we saw, and then we looked at the second variety of the function, which is called the other variety of function, which is called rational function, meaning a function where my variable is written in the form of a rational number, and that gives us a very unique scenario where we see it comes across for certain value of one of the variables, the overall value of the related variable, right, y, becomes undefined. So that those values are plot axis, which are called asymptotes. So you will see that this is pretty much symmetric around the asymptotes. It's like you will see, if you look at this, it look like a flipped mirror image. Again, this one, if you look at this, it will also look like a mirror image with a diagonal movement. So the asymptotes, those look more like a mirror, inverted mirror, for showing you a the graph, the two sides of the graph, which look like an image of each other. Any questions so far? I know these are not very lightweight concepts. These are loaded ones, and if sometimes I am kind of going with what I understand versus what you understand, kind of a thing, I might make it a little complicated. You might find it a little difficult also to begin with, when I'm teaching something, right? See, I don't have a silver bullet to teach everything in one go, and I don't do it right all the time, right? In the first go. So when we learn something, my request to you would be, after you attend the class, after you go through it, try to read it by yourself also, because some of the things that I explain my way, you might find a different, interesting and easier way to get it for yourself. So you also go through the same topic by yourself after having attended the class, and then try watching the video to see if you are able to connect the dots, if you are able to build your own understanding from that. And if that is done, we are done for that topic. If after doing those three things, attending the class, trying to follow what we are doing here, plus reading it by yourself one more time, watching the video one more time, and then taking notes, if these things help you build your own understanding in your own way, and then you are able to solve it, nothing like it. But if these three attempts are not helping, then for that particular topic, you can always tell me that, sir, this one we did not understand, explain one more time. And I'm perfectly fine doing it. Hello, Aditi. You have joined probably, okay, you have joined on time. We are just wrapping up the other class, okay? Just bear with me for a few more minutes, okay?
Okay.
Yeah. So, yeah, so that's something that wanted to let you guys know. There will be some concepts, like in the higher classes, there will be some concepts that will not be very easy to digest. But yeah, that is the way to kind of catch up on that. But any questions so far with respect to what we have tried learning? Easy, difficult, complicated? I don't know. If I don't see your faces, I would not know how confused you guys are. Huh? Easy?
Yeah.
Okay. Isha, Rutvik, everybody able to follow me?
Yes, sir.
Okay. Not wasting your time, right? Okay. All right. Now that's important. So I wanted to solve those 4 sums also in the class, but just because I took a little longer to explain these things. But this certainly brings us to the end of this unit. I will solve those 4 sums for you, Isha, and I'll send those solutions for that as an audio, as a solution in the notebook itself. Let me try doing it. I'll send it across to you guys. And if there's still some doubt, let me know. I will not try to use the next class for explaining that. Rather, I would try to do that in the offline itself, so that we can make better use of the upcoming classes. Okay. So let me try solving those 4 sums for you guys. Okay, and send it to you. And I'll make sure that I explain that in a simplest possible way, so that there is no ambiguity around how to solve those sums. Yeah.
Sir.
Okay. Isha, does that work?